Monte Carlo methods play a crucial role in climate modeling, helping scientists understand and predict complex climate systems. Since climate patterns involve uncertainty, variability, and numerous interacting factors, Monte Carlo simulations allow researchers to explore different possible future scenarios and assess risks associated with climate change. Why use Monte Carlo in climate modeling? Climate systems are influenced by a vast number of variables, including atmospheric conditions, ocean currents, greenhouse gas emissions, and human activities. Traditional deterministic models struggle to capture the full range of possible outcomes. Monte Carlo methods help by simulating thousands of climate scenarios to estimate possible futures, accounting for uncertainty in climate variables and model parameters, improving predictions of temperature trends, precipitation patterns, and extreme weather events. Applications of Monte Carlo in climate science. Monte Carlo methods are widely used in different aspects of climate research, including temperature and precipitation forecasting. Monte Carlo simulations help analyze how global temperatures and precipitation levels will change over time. Scientists use historical climate data to estimate variability, probabilistic models to explore different emission scenarios, large-scale simulations to assess temperature rise under different conditions, extreme weather event predictions. Understanding extreme weather is crucial for disaster preparedness. Monte Carlo techniques help predict the likelihood of heat waves, hurricanes, and heavy rainfall events, long-term droughts and their impact on agriculture, rising sea levels and coastal flooding risks, carbon emission and policy analysis. Monte Carlo methods help evaluate the effectiveness of different policies aimed at reducing carbon emissions by modeling the impact of emission reduction strategies on global temperatures, the uncertainty in human behavioral responses to climate policies, the probability of meeting international climate targets, such as the Paris Agreement goals, ocean and atmospheric circulation modeling. Oceans play a major role in regulating global climate. Monte Carlo methods are used to simulate changes in ocean currents and their impact on weather systems, assess the probability of shifts in climate patterns like El Niño and La Niña, predict the effect of melting polar ice on sea level rise, biodiversity and ecosystem impact simulations. Climate change affects ecosystems and biodiversity. Monte Carlo simulations are used to model species migration patterns in response to rising temperatures, assess the risk of habitat loss and species extinction, estimate changes in agricultural yields due to shifting climate conditions. Challenges of Monte Carlo in climate modeling. While Monte Carlo simulations provide valuable insights, they also come with challenges. High computational costs due to the complexity of climate models, dependence on accurate input data for reliable predictions, difficulty in capturing long-term feedback mechanisms in climate systems. Conclusion: Monte Carlo methods are essential for understanding the future of our planet. By running thousands of simulations, scientists can better predict climate trends, assess risks, and develop strategies for mitigation and adaptation. As computational power increases, Monte Carlo techniques will continue to improve the accuracy of climate models, helping societies make informed decisions to combat climate change.